Okay, so we're going to be finding volumes of solids and revolutions, and we're going to be doing the disk and washer method for this one. They're essentially the same method, except the washer has a hole in the middle of it that we got to take something out of. Okay, but the idea behind all of this is, let's suppose that you have a cylinder. Okay. So if you've got a cylinder with some radius r and a height h, then the volume of that cylinder is pi times r squared h, correct? Well, that's all we're going to be doing. Okay? But we just have to create the cylinder when we rotate around some particular axis. Okay? So here we have the y equals x cubed, y equals 8, x equals 0. We want the region that's bound by those things. So the y equals x cubed, since we're bound with x equals 0 and stuff, we're just going to do this part of it. Okay? And then y equals 8, line up here somewhere. And the x equals 0, of course, is the y-axis. So what we're doing is we're spinning this thing around the y-axis. So this is our axis of rotation. Now, if you can imagine that, you're going to make like a bowl shape. So when you spin that sucker around, what you're going to wind up with is something that kind of looks like that, right? Now, with the disk method, let me erase this so I won't get too messy. With the disk method, what we're going to do is we're just going to look at one little rectangle at a time, just like with integration and stuff like that. We just look at one little piece. And you always want to set your rectangle up perpendicular to your axis of rotation. So I'm just going to draw a little rectangle right here. I have to draw my little pictures, otherwise I wind up getting stuff wrong. Okay? So I draw this rectangle in here, and it's perpendicular to my axis of rotation, and it's inside of the region that I'm rotating. Now, the little part of the rectangle is on the y-axis. That's the delta y. It's a change in y, right? Now, imagine spinning this thing around the y-axis. Okay? What you're going to get then is you spin this thing around, is you're going to get this disk. Okay? And the radius is the length of that box, and the height is the delta y. Okay? Now let me erase my outside edges here. So the radius then is whatever this x coordinate is, because that's how far it goes out, right? It starts at 0 and it goes out to the x coordinate. That's the radius. Well, because I have a delta y, this part right here tells me I want everything in terms of y. So that means instead of an x coordinate, I need to look at that equation and say, okay, well, what does x equal in terms of y? So if I solve that for x, and that was supposed to have been a cubed, yes, that looks more like a square. That's the cubed root of y. So my radius then is the cubed root of y. So setting up my equation for my volume then, my volume for that little rectangle is pi times the radius squared times the height. Now that's just the one little rectangle, right? What we have to do, and what we are doing, is we're doing that for all of these rectangles that are in here, right? So we got all of these things. And what does that look like? That's an integral, right? Because an integral is an infinite sum. So to get the volume for the whole shape, we're going to integrate. We're starting at 0, and we're going all the way up to 8, because we're going from the bottom to the top on this one, since it's in the y coordinates. And we'll have pi. Now I'm going to write this as an exponent, so 2/3, and then we'll use dy instead of the delta, since we have infinitely many things. We're doing the integral. It's just a different notation, right? Well, and then we just need to integrate that. And that's all there is to it. Okay? So what do we get here? That's going to be pi times, we'll add 1 to the exponent. So that's going to be 5/3. Divide by that new exponent. We'll evaluate that from 0 to 8. And that's going to be 3 pi this. Now 2 to the 5th is 2, 4, 8, 16, 32. Minus 3 pi over 5 times 0. So that's just going to be what? 96 pi over 5 would be the volume for that solid. All right, so I've got 4 examples here, so let's move on to the next one. Each one of them is a little bit different. So here we're going to revolve something around the x-axis, okay? And let's see what happens here, what our shape looks like. So y equals x, just straight line through here. And then y equals x squared is this parabola, okay? And we're revolving around the x-axis. Now notice there's some space in between the x-axis and the region that we're rotating, because the region that we're rotating, of course, is this stuff that's in here. Okay? Now, because there's a gap in there, see if I can get this one. Of course, that's not going to erase. All right, stupid computer. Because there's a gap in there, what's going to happen when I rotate that around, I'm going to get this little disc, but there's going to be a hole in the middle of it. Okay? So it's going to look something like that, where we're going to look at the volume of the whole disc, okay? And I'm going to call that the outer radius. So I'm going to put an R0. So the volume for that is pi times the radius squared times h, and that's the outer. And then we're going to have an inner. I'm going to call that I. That's just going to go from the middle to, well, the little piece of the circle we're taking out of that. And that's supposed to be an I there. So that's going to be pi times the inner radius squared times whatever the height is. Now, when we draw this little rectangle, of course, we want it perpendicular to the axis of rotation. So it's going to be here, and we keep it inside of the region from the top to the bottom in this case. Now, notice the little part is along the x. So that means I need to integrate with respect to x. My height for my cylinder over here is going to be delta x. Okay? So the outside radius is from here all the way to the axis of rotation. Okay? So that's going to be whatever that y coordinate is. But of course I need it in terms of x, right? So my outer radius is, well, that's on the straight line. So that's just going to be x, because y equals x on that line, right? The inner radius, you pick a different color for that one. The inner radius is from here to the axis of rotation. So the inner radius goes to the little curvy one, and that's going to be x squared. So the volume for that little rectangle, when I spin it, is going to be pi times the outer radius squared times the height. And then we have to subtract the inside piece of it off, which is pi times the inner radius squared times the height. It's supposed to be a delta x. So that gives me my formula I need to integrate. So we're going to integrate. We're starting over here at 0, and then we're ending way over here wherever they intersect. So I need to find that intersection point. So the intersection point, just set the equations equal to each other. Where is x equal to x squared? And that would be, ta-da, when x equals 0 and 1. So I'm going to integrate from 0 to 1. And I'm going to factor out the pi, and I'm going to write it in front. We're going to have x squared. Hold on, this was supposed to be x squared squared. There we go. Minus x to the fourth, and then the dx. Right? So I factored these things out as well. All right. So pi, and then that's going to be 1/3 x cubed. Add 1 to the exponent, divide by the new exponent, minus 1/5 x to the fifth. We'll evaluate that from 0 to 1. It's going to be pi, and it's going to be 1/3 minus 1/5 minus 0, of course, because we'll have 0 minus 0. And let's see, getting my common denominator, that's going to be 5/15 minus 3/15. So that's going to be a 2/15 times pi. And our volume then is 2 pi over 15. Okay, now let's take that same shape, and I'm going to rotate it instead of about the x-axis over here. Let's go around with the line y equals 2. All right, so I'm changing then what we're rotating about, okay? But I'm keeping those same lines because it's kind of, I think, instructional to keep the same shape and just change the axis rotation so you can see how the radius changes and not have to worry about too many different things. So we have the y equals x, and the y equals x squared. We know it's still crossing at 1. Okay? Now this time y equals 2. Our axis of rotation then will be up here. And you know what, just so I don't have too much mess, still want to label things though. Okay, so we're spinning it then about a different little spot, and that's this axis up here where y equals 2. Alright, so rectangle is still perpendicular, so the rectangle still goes this way, but now you'll see what happens, and we're still going to have a disc with a hole in it, alright, when we spin that. And so the outer radius is always from the x-axis, always from the axis of rotation to the furthest part of your little rectangle. So that's from here all the way down to here. Okay, that would be your outer radius. Okay? So for that piece of it, our volume, we're going to have pi. Now, what is that distance? That's from 2 all the way down to this. And if you're trying to find just think about a number line, okay? And let's say we had 1 and 5. Okay, what would be the distance between 1 and 5? You always take the big one minus the small one, right? And we know that it has a distance of 4 between those. So what we're going to do to find the distance for that radius is going to be 2 minus, and then what is our x coordinate here? That's on that x squared, so it's going to be 2 minus x squared. Okay. And then we'll have the dx. Now the inside radius will be from our axis of rotation to the closest part of the rectangle, which is just the y equals x. Remember, we're going to have to subtract that off. So that's going to be 2 minus x. And I have to square those. I left that off. Okay. Delta x. So that's the volume for that little rectangular piece when we spin it around. Which means then that gives us our integral. We're still going to go from 0 to 1, okay, because that's where the region is bounded for the x-coordinates. I'm going to stick that pi out in the front. 2 minus x squared squared minus the 2 minus x squared dx. Now when you come across something like this, I strongly suggest just going ahead and multiplying this stuff out, simplifying it as much as you can. So that's going to be 4 minus 4x squared plus x to the fourth minus 4 minus 4x plus x squared. And then I'll combine my like terms. Let's see, 4 minus 4 is 0. And then we've got a negative 4x squared minus an x squared, so that's a negative 5x squared. That takes care of those. There's an x to the fourth and a plus 4x because we have the minus and the negative here, right? And now we'll go ahead and find my antiderivative. Okay, so that's going to be negative 5/3 x cubed. Add 1 to the exponent, divide by the new exponent. 1/5 x to the fifth plus 2x squared, because we add 1 to this to get the 2, and then we divide by 2, right? And then we'll evaluate those at 0 and 1. Okay, and at 1, negative 5/3 plus 1/5 plus 2 minus, and then, well, if we put 0 in for all of those, we're still just going to get 0. And negative 5/3, that's going to be 15, right? So negative 25 plus 3 plus 30 over 15. And I don't have room on that next page yet, so that's just pi, and that would be 5/8/15. So I cannot write 8 pi over 15. And so that's going to be our volume for that shape when we rotate it. Now these where the axis of rotation is different than the x or the y-axis is a little bit trickier. So I'm going to do one more, and this time I'm going to go around a different line, and I'm going to have this one, let's say, instead of the x-axis, let's go with x equals 3. Sure. Okay. Yeah, that's good enough. So again, the straight line, and then we have this part, right? Now x equals 3 is out here somewhere, and that's what we're spinning that sucker about. So the outer radius is always from the axis to the furthest part of the rectangle away. So here's my rectangle. So my outer radius goes from here all the way over. So my outer radius then is going to be 3 minus, and this needs to be in terms of y, because the skinny part of my rectangle is kind of pointed to the y-axis, and that's the line y equals x. So that's just going to be 3 minus y. The inner radius is going to be from our axis of rotation to the closest part. Now that is y equals x squared, right? So x, we have to solve that. We have to have everything in terms of y. So that's the x is equal to square root of y. Okay? So the inner radius then is going to be 3 minus the square root of y. So setting up my volumes then, I have pi times the radius squared times the height, oh, that's a dy, minus pi times the inner radius squared times the height. So that's the volume of that rectangle, and then the volume of the whole solid then. Now the y-coordinate, now this point up here is actually the point 1, 1. Whoa, get back where you belong, stupid video thingy. Okay. And so we're integrating along the y-coordinates. So that's going to go from 0 to 1 again, but this one is the y-coordinates. In the previous example, remember, we were doing the x-coordinates. And I'm going to stick the pi out front and then the dy, at the end. So this is just going to be 3 minus y squared minus 3 minus square root of y squared. And again, I'm going to simplify, so that's 9 minus 6y plus y squared minus, it's going to be 9 minus 6 square root of y plus y. Let's see, 9 minus 9, we'll have a negative 6y minus y would be negative 7y. Takes care of those. I have a plus of y squared plus 6 square root of y, so I'm just going to write that as y to the 1/2. I have a dy there. Alright, so that's a 7/2 y squared plus 1/3 y cubed plus, alright, so this is going to be y to the 3/2. And then we're going to have 6 times 2/3. And that'll be 4. And we'll evaluate that from 0 to 1. And so that's negative 7/2 plus 1/3 plus 4 minus the 0, of course, we're going to get there at the end. And let's see. A common denominator is 6, so that's negative 21 over 6 plus 2 over 6 plus 24 over 6. Yeah. Okay. So that would be 3, 4, 5. So that would be 5 pi over 6 would be the volume for that. Okay. So that's how you do the disk washer method stuff. It's all based off of course, having just a disk or possibly a disk with a hole in it. And it's always, and you've known this formula for a long time now, that the volume is going to be pi r squared h. Okay? And if it has a washer in it, you know, if it's got a hole, then you got to subtract off that middle cylinder as well. But it's the same formula, right? You just subtract off the smaller piece. So hopefully this will help, and have a wonderful afternoon or evening or morning or whatever it is.